In this video, I am going to find the domain of this given function f of y is equal to f of x is equal to negative 2x plus 1 divided by x square minus 5. Please note that this function involves division, so we call it a rational function. When you're dealing with division in a function, you have to always make sure that the denominator does not evaluate to 0. That means you cannot divide by 0. So you have negative 2x plus 1 on the numerator, and you divide it by some number, x square minus 5. You want to make sure that this x square minus 5 does not become 0. If it does, in that case, you are dividing by 0, which will lead to an undefined value. So that means you want to exclude those values of x, which will make the denominator 0. So what we are going to do, we are going to write x square minus 5, the denominator, and we just try to find out what value of x will make the denominator 0. And just by observation, if you just look at it, you can see kind of like, if you think a bit about it, if you put x is equal to square root of 5, then you get x square, square root of 5 square. This square and square root is going to cancel out. That's going to give you 5. So in that case, my x square minus 5 is going to be square root of 5 whole square minus 5. This cancel out, which gives me 5 minus 5, which is 0. Oh, by the way, that cannot happen. So you do not want x equal to square root of 5. So you don't want this value. As it turns out, if you plug in x is equal to negative square root of 5, that also will give you 0, because if think of it like this, if x is equal to, let's say y, let's use y. If y is equal to 2, y square is equal to 4. If y is equal to negative 2, then also y square is equal to negative 2 whole square, which is also 4. So using that logic is going to be square root of 5 and negative square root of 5. So you don't want these two values. Okay, that's the domain, by the way. Basically all the real numbers on the number line except for square root of 5 and negative square root of 5. But I'm going to show you a different way of deriving this. So let's say this is my denominator. I'm going to factor it, x square minus 5. I can write minus 5 as square root of 5 whole square, because square root of 5 whole square is just 5 as it is here. Now you have difference of squares, so you could write it as x plus square root of 5 and x minus square root of 5. So I could rewrite this function as negative 2x plus 1 x plus square root of 5 times x minus square root of 5. Now as you can see very easily, what's happening, if you plug in x equal to square root of 5, this is going to be 0 and this is going to be non-zero. So product of a 0 and a non-zero number is 0. Of course this is a fixed number, I'm assuming, not infinity or anything. And similarly, if you plug in x equal to negative square root of 5, this is going to be 0, and in that case this is non-zero fixed number, so product of these two numbers is going to be 0. So these two values, this one and this one, will give you 0 in the denominator of the function, which means these values will cause the function to be divided by 0, and that cannot happen. So your domain is going to be all the numbers on the number line except for negative square root of 5 and positive square root of 5. Now you make two big circles and you exclude those points, so you don't shade the circles, so you shade everything else in between, everything else to the right, and everything else to the left. So that's what it is. And in the interval notation, if you want to express it, is going to be, you start from negative infinity, right? So negative infinity, from there you come to negative square root of 5. Do you include or exclude that point? You exclude it, so you put closing parenthesis, then you put a big U union, then you start from negative square root of 5 right here, and then do you include this point? No, you don't. So you put an opening parenthesis, so negative square root of 5, comma, where do you go to? Positive square root of 5. You stop there, positive square root of 5. Do you include this point? No, you put a closing parenthesis, then union. Again, you start at square root of 5, you do not include this point, so you put opening parenthesis, square root of 5, then you go all the way to infinity. So this is your interval notation and this is your number line notation. So both help you kind of see things. So let me summarize. What did we do here? I have taken a rational function and found the domain by considering the x values which will yield 0 in the denominator, and I have excluded those x values from the domain. That means from the number line in this case, and the remaining numbers are going to be in the domain of this given function, which is shown by this and this. I hope that this discussion was helpful. Thank you very much.